Welcome viewers, in this video we'll see the details about T flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. T flip-flop. We know that flip-flop is the storage element. It will store one bit of data. The output, we have two stages available, present state and next state. So the next state output is depends upon present state as well as the input. So the output is depends upon earlier available output as well as the input. So this is about the basic of flip-flop. Now we'll go to the T flip-flop. T flip-flop is also known as toggle flip-flop. Output is toggled. This T flip-flop is modification of JK flip-flop. That is, T flip-flop is obtained from a JK flip-flop by connecting the both inputs J and K together. J and K get the same input. That is nothing but T flip-flop. If we give the same input to J and K inputs, that is the T flip-flop. Now we will see the logic diagram of the T flip-flop. So this is the JK flip-flop. J 1, 2, 3, 4 NAND gates are available. This first NAND gate J input, second NAND gate K input, then it is interconnected. So in this we are giving the same input. This is a T input, only one input is given to J as well as K. J and K getting the same input. One more input is clock pulse. We know that it's a sequential circuit. Every clock pulse the stages will changes. And one more input for this NAND gate 1 got from the Q bar. Q bar is also one of the input. For second NAND gate is the Q. Q is the one of the input. Right. So the first NAND gate got T input as J as a T input, clock pulse and Q bar. Second NAND gate gets same T input as a K input. Then clock pulse, then Q. Right. So this output of first NAND gate is connected to third. Second NAND gate is connected to fourth. This third NAND gate, one more input is Q bar. Fourth NAND gate, one more input is Q. That is interconnected. So that we got Q as the output, Q bar is the complement of the output. So this is the basic logic diagram of the T flip-flop. J and K getting same input. For one sample output, we will verify the output, whether it is changes, how it is changes. After the truth table, we will verify this. I will see the description and truth table, then we will verify one sample input. So this is the logic symbol, JK flip-flop, output and complement of output and clock pulse, same input is given. T as the input given for J as well as K. This logic symbol can be modified as single input J and complement of output and complement of output and clock pulse. So this is a real symbol, this is a modified having one input. Then we will see the truth table and excitation table. So the truth table, this is the T input. This is the present state. This one is next state. Qn T Qn plus 1. We already know that the next state of output is depends upon the input as well as earlier available output Qn. Right? Qn plus 1 is depends upon Qn and input. So Qn and T, two variables, 2 digits. So 4 combinations available, 0, 0, 0, 1, 1, 0, 1, 1. Right. So the T equal to 0 means there is no change. What is the present state? That will be the next state. T equal to 1 means present state 0 means that will be toggle. 0 become 1. If T equal to 1, the present state will be toggle. 0 means it become 1. Again, T equal to 0 means present state is 1 means next state also 1. No change. 0 means no change. Again, if T equal to 1 means present state is 1 means it will change to 0. Right? So T equal to 0 means no change. T equal to 1 means 0 become 1, 1 become 0. Right? So the same truth table written in another manner, T Qn plus 1. This qn plus 1 depends upon qn and t. 2 variable, 4 combination. 0, 0, 0, 1. This t is 0 means no change. T is 1 means 0 means 1, 1 means 0. Toggle. So here it is very clear. T is 0 means no change. 0 means 0, 1 means 1. T equal to 1 means toggle. 0, present state 0 means next state 1. Present state 1 means next state 0. Right? So both are same. It is written in a different manner. Now from that we can go for the characteristics equation. So this is the modified. T0 means Qn plus 1 is Qn. Both are same. T1 means Qn plus 1 is Qn bar. Toggle. 0 means 1, 1 means 0. Say T0 Qn. T1 means Qn bar. Now from this we can go for a K map. Qn is the one input. T is the another input. From that we can find Qn plus 1. Here 0, 1, 1, 0 is there. So it is 0, 1, 1, 0. So not possible to combine. Both are available individually. So the characteristic equation is Qn plus 1 equal to T Qn bar plus T bar Qn. So characteristics equation. Now we'll see the excitation table. What is excitation table? The present state and next state. From that we need to identify what is the input. Truth table means from input we are checking what is the output. Now output, for this output what is the input required, that is called excitation table. For example, present state also 0, next state also 0 means what is the input, what is the value of t. Present state is 0, next state is 1 means what is the value of t we need to give, that is called the excitation table. So qn plus 1, 2 bits, so 4 combination 0 0 0 1 1 0 1 1. We'll check the first one. Present state is 0, next state is also. From here we'll check. See, this is the present state is 0, next state is also 0. And what is the input? 0. We need to give t as 0. If it is 0 1, present state is 0, next state is 1. Here it is available. Present state is 0, next state is 1 means the t value is 1. Then 1 0, it is available here. Present state is 1, next state is 0 means the t should be 1. Both are 1. That is available here. Q1 is also 1, Qn plus also 1. For that, the t input is 0. Right? So for this 4 combination, we decided t1. Suppose if you want to maintain, you want to change, present state is 1, next state should be 0 means the input what we need to give is 1. That is called excitation table, right? I will explain again. 0 0 means t is 0. 0 0 means t is 0. 1 1 means also t is 0. 1 1 means also t is 0. 0 1 means t is 1. 0 1 means t is 1. 1 0 means 1 0. 1 0 also t is 1. Right? Okay. Now we'll check the one of the input. One sample input will verify. We'll take this. The t input is 0. Input is 0. Output is 1. The same 1 should be maintained. Right? Input 0. Present state is 1. Next state also should be 1. Now we'll check this with the logical diagram. So in this logical diagram, input is 0. Output is 1. The same 1 should be maintained. Now we'll check. If q is 1 means q bar will be 0. Right? T is 0. Q is 1. Q bar is 0. So the same 0 is given to NAND gate 1 as well as NAND gate 2 as a J, K inputs. One more input is clock pulse. Both are 1. This NAND gate get Q bar as a one of the input. Q bar is 0. So 0, 0, 1. This NAND gate get Q as a input. So this 1. Q is 1. So it got 1, 0, 1. Right? So 0, 0, 1 means the answer is 0 for AND gate. NAND gate means it is 1. Similarly here 1, 0, 1 means 0, but NAND gate it will give 1. Right? So the output of first NAND gate is 1, second NAND gate is also 1. Now this third NAND gate get Q bar as a one of the input. Q bar is 0. Right. Now we'll follow from top to bottom. We have to follow certain procedure. Both are interconnected. We don't know which one will be executed first. But we need to consider first we'll execute 3, then we'll go for 4. We have to follow the certain procedure for theoretical understanding. Right. So the third NAND gate get 1 as one of the input, 0 is another input. 1 into 0 means 0, because of NAND gate it is 1. See, the same 1 is maintained. Now this 1 is applied here. 1 into 1 means 1, NAND gate means 0. Right. So the same stage is maintained for t equal to 0. Right. Q is 1. After executing, the Q is also same, 1 is maintained here also. Right. We already know that t is 0 means no change in the output. Present state and next state is same. That is what we discussed. If t equal to 1, the present state next state will change. 0 means 1, 1 means 0. So in this we discussed about the T flip-flop. That is a modification of JK flip-flop having same input to J and K. We discussed logical diagram, logical symbol, truth table, then excitation table. Excitation table means output. For the given output we are checking what is the input required. Then we verified one of the input also. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.